Okay, so I like to do this from time to time. We'll see how consistent I can be. But I call them Rob Types videos. And basically, well, I have to write solutions to these problems. And so essentially what I like to do is I like to write the solutions and kind of discuss them as I write them. So that's what we're going to do here. This will also give you some familiarity with LaTeX. Though obviously I'm not going to post these until after this is due, so whatever. Okay, but for the next homework assignment, you'll get some idea about how to do LaTeX if you watch this. All right, so we want to find the Fourier transform of f of ax. Okay, basically what I'm going to start off with, I'm just going to say by definition, this is what the Fourier transform is. If you want to kind of like write math that's kind of like not in the, like not in line, but kind of, you'll see. You could either write the math in line as a paragraph or kind of like write it as a quote underneath, like a block underneath. That's what we're going to do here. Okay, so hat f of omega. Now I'm going to be using omega a lot, so I'm going to come up here and make a new command. I'm going to say new command w. That's the name of the command, and it's just going to be omega. So wherever I do, so in LaTeX, the commands are backslash and then whatever the command is. So backslash w means backslash omega, or sorry, wherever LaTeX sees backslash w is going to put backslash omega, and omega is going to be the omega. That's what it is. Okay, so this is equal to the integral, and I like to explicitly say like x equals minus infinity. So infinity is infty to plus infinity. And the reason is because there's several variables. There's x and omega, and I want to make sure that we're doing that we're looking at the right variable. So you have f of ax, and then e to the minus I omega x dx. And I'm just going to compile this so we can see what it looks like. Okay, that's what we have here. Okay, now here's the idea. What we want to do is we want to say, okay, I want to have f of x there, because I want to kind of write this in terms of the Fourier transform of f. So I want to have f of x there. So I'm going to introduce a new variable. I'm going to say let u equal a times x. So then in the new integral, instead of having an a times x, there's just going to be a u. So this means that du is equal to a dx, or dx is equal, and to do a fraction, you do frac. It's a command that takes two arguments. Like this w command, excuse me, this w command doesn't take any arguments. This command takes two arguments. The first argument is going to be the top of the fraction, the numerator, and the second argument is going to be the denominator. So this means dx is going to be equal to du over a. And the integral is going to become the following. Whoops. Okay, so we're going to have, I'm just going to copy and paste this. Okay, so notice I'm going to do an ampersand here. And this double line puts us onto this double backslash gives us a new line, and the fact that I have an ampersand there and an ampersand there aligns the equal signs. Okay, and this is going to be equal to the integral. Okay, so u is equal to ax. U is equal to ax, so we're going to have minus, if u is equal to ax, u is going to be going from minus infinity. It's really like minus a times infinity. And there's a problem here you might be catching on if a happens to be a negative number. But let's set that aside for now and come back to fix that. So we're going to have f of u because u is equal to a times x. Okay, so now x, if u is equal to a times x, then what this means is that x is equal to u over a. So this is going to be e to the minus I. I'm going to do w over a u du. Sorry, not just du. Dx is equal to du over a. So this is frac du a. Okay, so again, this works completely fine right now if a is positive. We're going to see what happens if A is not positive. Whoops, I did Control C. Control S. Control S also recompiles. So that's what we have here. Okay. If I continue this, this is equal. I'm gonna move that A out, and we're gonna have the integral u equals minus infinity to plus infinity f of u e to the minus I omega u, or sorry, a u, and then just d. Let me see how that looks. Okay, that's good. Okay, now again, if a is positive, what we're doing here, this integral right here, this is just the Fourier transform of f, but evaluated at omega over a. And so this, oh, you know what? I forgot the 1 over the square root of pi. It's not going to change anything. I'm just going to have to put this. Okay. Everything is going to stay the same, except I need to write this. So I'm going to have it here. I'm going to have it here. I'm going to have it here. And then this is equal to frag 1a. And then it's going to be equal to WA. Okay. Okay, but notice we need to still figure something out here. Everything works here exactly as we have it if A is a positive number. Everything works here exactly correctly if A is a positive number. Okay, but let's think about what happens if A is a negative number. Okay, so let's think about what happens. I'm going to change some things up here, and then we'll see everything. We'll figure out a way to make this work if A is positive or negative. So let's see if A is a negative number. Let's see what's going to happen if A is a negative number. So if A is a negative number, if I look at this line right here, once I've made this substitution, well, this A here is really going to be minus times the absolute value of A. Okay, but there's actually a command up here for absolute value somewhere. I've got a lot of commands. So backslash abs gives us this. We're going to get something like that. Okay, so it's going to, if A is negative, this is if A is negative. So what I'm talking about now only works if A is negative. If A is negative, it's going to be minus absolute value of A. But now the limits here, if u is equal to A, x, and A is negative, then if u is equal to ax, and A is negative, and x is equal to minus infinity, then minus A times minus infinity is positive infinity. And so this is going to be positive infinity here, and negative infinity here. Okay, so just think through what I'm saying here. If we change the limits, but A is negative, the bottom limit will now be positive infinity, and the top is negative infinity. Okay, but notice what's going to happen. If you multiply the integral by -1, you can flip the integrals. So this minus, or flip the limits of the integral. So this minus sign here is going to flip the integrals there, or flip the limits of the integral here. And what we're going to have is the following. It's going to be minus, like this. Okay, so this is what it's going to be here. Okay, absolute value of A. That's exactly what we had before. I just need to change this integral right here to the absolute value of A. And I need to change this to the absolute value of A. Now, notice that this is exactly what, if A is positive, the absolute value of A is just equal to A, and this is what we're going to have here. Okay, so note, now, you might not necessarily have just watched all of that explanation, so now I want to explain why there's an absolute value of A, because it doesn't seem like, where does that come from? Note that we have absolute value of A because if A is less than 0, then the limits of the integral after doing the substitution are and du over a is equal okay, then let's see. Let me see how that looks. Note that we have the absolute value of a because if a is less than 0, the limits, let me get rid of the then. The limits of the integral after doing the substitution are this, and du over a is equal to du over minus the absolute value of a. Okay. And the minus sign there flips the bounds on the integral. Okay? So now we have to ask a question. We know what happens if a is positive. We know what happens if a is negative. What happens if a is equal to 0? Well, if a is equal to 0, what we're doing is f of 0 times e to the minus I omega x. So if a equals 0, this is equals f of 0 times 1 well, what is this? This is just going to be f of 0 times the Fourier transform of the function 1. I'm going to do like this, 1. I don't know how that's going to look. Let me see. Okay, looks kind of weird, but that's okay. But now we have to remind ourselves, what is the Fourier transform of the constant function 1? Well, that is equal to the square root of 2 pi. That's equal to the square root of 2 pi times the delta distribution. Okay, I actually want to put this here. Okay, and so that's what we have there. Maybe just to make this look symmetric, I'm going to make this all on different lines as well. Okay, and so there we have it. That's the answer. Now, typically, probably when we're thinking about this, we might be thinking about a as being a positive number. Typically, we're not going to think about it being equal to 0, but this is what it is for all of the different cases. That kind of looks weird. Let me see how it looks if I do this. How does that look? Yeah, whatever. It looks weird either way, right? Okay, that is all for this video.